Hello dear students of physics, medical and non-medical respected teachers. Today I am going to discuss another part of magnetic effects of current known as Ampere's Circuital law, and I will discuss one of its application in this video. So state Ampere's Circuital law. It states that line integral of magnetic field over a closed path, that is line integral B dot dl in vacuum is equal to mu naught times the total current flowing. So line integral B dot dl is equal to mu naught times I is the total current flowing. Now to prove it, suppose we have straight wire carrying current and we know that it produces magnetic field around it. Direction of magnetic field is given by right hand thumb rule. Thumb points direction of current and magnetic field will circle around the wire like this. So suppose P be any point on the circular path or circular magnetic line of force having radius r, let dl is equal to length of this small element at r and B is equal to magnetic field at r. So magnetic field B and dl vector are in the same direction because magnetic field is tangent to the magnetic line of force and dl vector is also tangent to the magnetic line of force. So magnetic field at P at distance r due to straight wire, infinite long straight wire carrying current is given by B is equal to mu naught I by 2 pi r. Question number 1. Now let us calculate line integral of B dot dl over closed path. It will be B dl cos theta because A dot B is equal to AB cos theta. But in this case theta, that is angle between B vector and dl vector, is 0. So cos 0 is equal to 1. Therefore line integral B dot dl over closed path is equal to mu naught I by 2 pi r, such the value of B dl. Now mu naught I by 2 pi r can be taken outside the integration. It will be integral closed path dl. So total integral of dl over closed path will be equal to 2 pi r, circumference of circle. So 2 pi r cancels. So we get B is equal to mu naught, line integral B dot dl is equal to mu naught times current, which is a proof of Ampere's Circuital law. Very simple. Now here we have consider circular path and wire carrying current at center. Now this law is true for any closed path, any arbitrary closed path. Suppose again wire xy carrying current I and arbitrary closed path like this. Then suppose Mn is a small segment of this closed path of length dl, making angle d theta at the center at distance r. Now, because segment is a very small length or dl is very small, so this chord or arc can be taken equal. So then by definition of angle, small angle is equal to arc upon radius. So d theta is equal to dl upon r, because in this case arc becomes the chord. So because Mn is very small, so small angle d theta is equal to dl by r, or dl is equal to r d theta. Therefore line integral B dot dl over closed path is equal to line integral B dot dl, that is B dl cos 0. Cos 0 is again 1 here, or mu naught I by 2 pi r integral dl over closed path. Now dl, such the value of dl here, r d theta, r can be taken outside the integration, so it will be closed line integral d theta. So B dot dl over closed path is equal to mu naught I by 2 pi. Now closed path integral of d theta will be 2 pi, because limits are 0 to 2 pi. Minimum angle will be 0, maximum angle will be 2 pi. Angle round a circle. So mu naught I by 2 pi cancels. So again B dot dl is equal to mu naught I. So it means Ampere's circuital law is true for any arbitrary closed path. Now it has so many applications. So I will discuss first application, magnetic field due to an infinite long straight wire carrying current. It's the same diagram. state wire carrying current, magnetic field in a circle around the wire like this. R radius of circle of the closed path, B magnetic field at that closed path, dl is length of the element. Then line integral B dot dl is equal to line integral closed path B dl cos 0 is 1, B line integral dl same. B dot dl closed path line integral is equal to B into 2 pi r. So equation number 1. Now we are doing the application of Ampere's Circuital law. So by Ampere's Circuital law, B dot dl line integral over closed path is also equal to mu naught times I. So compare these two equations, you get the result. So B into 2 pi r is equal to mu naught I, or B is equal to mu naught I by 2 pi r, which is the required expression for magnetic field due to infinite long straight wire carrying current at a point r. This is all about Ampere's Circuital law and one of its application to find magnetic field due to an infinite long straight wire carrying current. So Ampere's Circuital law is true for any arbitrary closed path. So be happy, all the best, good luck.